All right, we're going to continue on with session 2. That's still part of lesson 2. We're going to move to developing. So if you look at the top of your page here, it says develop. The page before said explore. So we're going past just finding it. Now we're going to understand a little bit more. Maria's class is painting a mural on a school wall. Staff and Okama's Cultural Center helped Maria copy an Okama Pueblo pottery design to use in the mural. Maria draws her design on a 1 centimeter grid paper, so we know our units are centimeters. She begins with one of the triangles. What is the area of her triangle, of Maria's triangle? Okay, so retelling the story in words that are more friendly to you. So Maria is going to make a pottery design. And this pottery design is a triangle that is shown over here on grid paper. The grid paper, each of them are 1 by 1 centimeters. So we need to find the area of her triangle. Well, we know from the previous session, we know still area of a parallelogram is base times height. I'm just going to do P for parallelogram. We know we do not have a parallelogram, but we can also look back and know that we made a parallelogram by using 2 triangles. So 2 triangles equal a parallelogram. So what is 1 triangle going to be? Well, if we look here and we go ahead and just trap that triangle in a rectangle, we can see that this piece on the left matches this piece over here. This piece up here is the same as this piece. So these 2 pieces and those 2 are the same. We can see that our triangle that is shaded takes up half of the entire parallelogram. So if it takes up half the parallelogram, then if we take half the area of a parallelogram, are we finding the area of our triangle? So just a couple of reminders. Area of the parallelogram is base times height. We made a parallelogram by capturing that triangle in the parallelogram. So if we're going to find the area first, that's base times height, we can count across. We will see that this is 8 centimeters. My height, remember, go to my vertex, drop a string. The height, so base is 8. My height is 4 centimeters. So my area of the parallelogram is 8 times 4, which is 32 centimeters squared. But we know that's not the area of the triangle. We know the triangle is half of that. So we're going to take half of 32. Half of 32 is the same as dividing by 2. And our area is going to be 16 centimeters squared. So the takeaway here is area of a triangle is half the area of a parallelogram. So area of a triangle is half the area of a parallelogram. So our formula for triangles is area equals 1/2 of our base times our height. Just to look at some problems on the next page. So on page 26, they talk you through this. So they talk you through what it means, and you can see how they decompose and recompose. Decompose, remember, they took off this section, duplicated it, and moved it over here to show you that it's the same. The same for these 2 triangles. So here's where I want to focus for a few minutes here. Write an expression for the area of Maria's triangle. Well, first of all, they're using some fancy looking parentheses to help us solve here. So I want to make sure we understand what this really means. So write an expression for the area. They broke it into 2 triangles, and then, 2 parallelograms, and then took half of both and added it. That's a lot of words, but what I want you to understand is anytime you see something like this, you see a half or any number touching a parentheses, it means to multiply. So what you would do here, you would take, I moved it on you. You would take your half, you would take your 2 times your 4 first, which is 8, and then you're left with half of 8. Half of 8 is 4. Okay, same thing here. They have half of 6 times 4. Okay, 6 times 4 is 24. And then you take your half and you get 12. Okay, their final step is they took the 12 plus the 4, added them together, and got 16, which is the same thing we got on the previous page. You can find the area, onto the model. You can find the area of a triangle by composing the triangle with a copy of itself to form a parallelogram. So composing it means to build. So you could duplicate the triangle that's on the page, make another one, and do the parallelogram. That's the strategy that I focused on. So my area is half of my base times height. My base is 8, my height is 4. Half of 32 is 16 centimeters squared. Okay, so the formula, remember, is half of your base times your height. Okay, these are the real questions. This is where the lesson kind of comes together for you to understand all of these pieces as one. So use the problem from the previous page to help you understand how to find the area of a triangle. How can you think of a right triangle as half of a rectangle? How can that help you find the area of the right triangle? So how can thinking of a right triangle as half of a rectangle help you find the area of the right triangle? So I'm going to draw a rectangle. What they're saying is if your triangle was here, how can making it a rectangle help you? You guys know rectangle area is base times height, right? The area of the rectangle is base times height. So you can divide that by 2 or take half. Look at the expression in the first model it. So if you go back to page 26 where it says model it, you can see the expression there. What does 1/2 of 2 times 4 represent? So 1/2 of the quantity 2 times 4 represent. How do you know? Well, that's area of half of that first parallelogram or first rectangle. So it's the area of the smaller triangle and we know 2 times 4 is 8. That's the area of the rectangle. And then you take half, which gives me 4 centimeters squared. Use the expression to help solve the area of Maria's triangle. Well, we did the first one. So we know the smaller one is 4 centimeters squared, the smaller triangle. The larger one is half of 6 times 4. Remember the dot means to multiply. That's going to be half of 24, which gives me 12 centimeters squared. So I'm going to take my 4 and I'm going to take my 12, add my 2 triangles together. My final answer is 16 centimeters squared. And that's what we got on page number 1 as well. Look at the second model it. So if you go back to page 26, the second model it. How are the base and height of Maria's triangle related to the base and height of the parallelogram? So if you look back, they are the same. Okay, 8 is the base for both. So it's the base of the rectangle and the base of the triangle. 4 is the height for both. They're the same. Okay, I'm going to go ahead. I want you to pause. I want you to solve questions 4 and 5 on your own. And then once they are solved, you can go ahead and turn the video back on. And we'll go over those 2 answers. So go ahead and pause, solve 4 and 5, and then come back. Okay, question number 4. The formula for the area of a parallelogram is area equals base times height. Explain why the formula for the area of a triangle is area equals 1/2 times base times height. Don't overthink this. Think of it as what did you draw? What have you seen? Well, we know that a triangle is half of a parallelogram. If a triangle is half the parallelogram, then its area also has to be half. Five, reflect. Think about all the models and strategies you have discussed today. Describe how one of them helps you better understand how to find the area of a triangle. This is on you in regards to what is better. Is it better to decompose it? Is it better to compose and make a rectangle and cut and paste mentally to form a full rectangle? Or are you somebody who likes just having a formula? Answers will vary on number 5, but I will tell you that I like to have something concrete with the understanding behind it. Meaning, I love that we can use a formula of area equals base times height, half of base times height, but I need to understand what that means. We have to be able to label the base, we have to be able to find the height, we have to be able to use the right dimensions, and then we have to be able to divide it by 2 to find half. So 5 is your choice, but make sure whatever you have there, you have an understanding. If not, go back, rewatch. Or when you get to the practice problems on page 28 that you will do in Class Kick, 6 through 8. If you're still struggling, that's when you need to either email or let me know, and I will help you with whatever I can.